Today, we're talking about the instant impact you can get if you can make your files global. So let's start by talking about the status quo. The companies that we talk to on a daily basis, their IT leaders will tell us they have file servers everywhere, Windows file shares everywhere. Half the time, they don't even know where they are. So it's a wildly inefficient situation. So legacy storage and file servers were never, ever made to work across distance. Your storage sits close to where your users are, and it's not a scalable situation. You need more storage, you'd buy another storage array. You can't scale your users out distance-wise. That creates enormous version control for files. And the way that you're managing files creates this exponential data growth, because in order to achieve any kind of file synchronization, you need to make copies of those files. And so if you have 4 locations, you can end up storing the same file, not to mention other versions of that file, at least 4 different times. And that's for your active data. Then there's your backup data. Then there's your offsite data. All of this is contributing to the gazillions of zettabytes of files that we currently have and are struggling with. Also incredibly difficult to manage because there's no centralized management function. Every single one of these servers has its own controls to a very large degree. And then when you have multiple sites, you have users across all of these sites, and so file sharing becomes incredibly insecure, because users will do all sorts of things to get files to where they need to get them to, including shadow IT. And so often that means those files are completely outside of your visibility. Large files are especially problematic because latency gets in the way. And so transmitting a large file from one site to another takes a long time. There's a large degree of corruption that happens. Remember, corruption is just about a file being inconsistent. It doesn't mean the file is unopenable. And so the situation you've created is one in which your productivity is seriously hampered by the way that you're managing files. It's fine if you just have one location and everybody comes into that office location. As soon as you have more than one, you're in trouble. When you start to get larger and larger, and you have smart people all over the place, then you get to a situation where you really need those people to be able to collaborate together, because if you don't, you're not going to get as good an outcome as what you're hoping for. So here's the thing. Delivering data over any kind of distance is really hard. And that's why not very many solutions do a good job of it. However, it is the one thing that's going to make the largest difference. If you think about the way that the things that you need to take into account when it comes to good data management, the first is you need to be able to see what it is that you're storing. The second is that you need to make that data resilient, because if you don't, nothing else matters. And the last one is data delivery. You need to be able to get those files to the people who need them when they need them. No delays, no corruption with files, no inconsistency. Your people need to know that what they're working with are the current files with the latest changes made. If you can get that right, you will put yourself in a situation where your projects take less time to complete. They don't take as many man hours to complete at the same time. Your people will be massively less frustrated. And you create a situation where, and I think we've all had this moment of thinking through a process and your files are not keeping pace with them. If you can allow people to work at the speed of their thinking, then good things happen. Your products become better, and you put yourself in this wonderful situation where you can actually work on innovation rather than just struggling to do bread and butter type work. And all of this is down to file delivery, assuming that you've taken care of file visibility and also file resilience. And yet, we're in a situation where the good old FedEx truck, more often than not, is used to get large amounts of data from one location to another. Don't laugh at this. This is the reality for firms every single day. And that's because moving data is hard. moving large amounts of data is extremely hard. And so how can you deal with this? Well, let's talk for a little bit about how Panzura uniquely delivers data across distance. Now, to begin with, we consolidate data. Panzura CloudFS is a hybrid cloud file services platform that at its heart has a global file system. We take data that's distributed across Windows file servers and we consolidate it into a single authoritative data set. We deduplicate it as we do that. And so we're squeezing a lot of replication out of your data. Across the board, we get about a 35% decrease in data volume. For some companies, that goes up to about 80%. All depends on the type of data that you have. Then we have the concept of all of the locations within your file system. And at each of those locations, Glenn's going to talk about this a little bit more in a moment, we put a virtual Panzura node, and that's going to give you some local performance because now you've got centralized storage, could be in the cloud, could be on-prem. You need some way of dealing with localized performance. Then you're going to give each of those locations a copy of the metadata of the whole system. You're going to split the metadata from the data. Metadata, of course, weighs very, very little. So it takes up very little space and it's very easy to move quickly. And then not only are you going to allow those locations to talk to the object store and either send data to it or extract data from it, you're also going to allow those locations to talk to each other. And so you're going to achieve the virtually impossible, which is a system that can send files, including changes, in real time to any user anywhere across the globe. Now, to show you how we do this step by step, I'm going to hand over to Glenn Schock.
Right. So traditionally, the issue with distributed file systems or global file systems is going to be performance relative to the savings associated with creating that global file system. Like Petra mentioned, the deduplication. If you have 10 sites, you probably have the same file stored 10 times, which is fantastic to be able to get that dedupe. But then what happens to local performance when you take away that local siloed storage system that you're used to? Panzura has solved both problems. Our virtualization at the edge, that system can be as robust as you want it to be. For example, we support 100 gig interfaces within those systems. We can support as many CPUs, as much cache as is required at the edge. Now, the interesting thing about the way file systems work is maybe 1% to 2% of the file system is quote unquote hot, right? Those are the files that are being utilized. When you break up that 1% to 2% across, let's say, 10 sites, you have a very small fraction of all of the available storage that's actually relevant to the user base at that site. So you can build a virtualized edge, CloudFS edge node with as much cache as is required. So we're talking about SSD speed disk for the users to see absolutely no performance difference between a siloed old type of storage system and a CloudFS edge node that is actually connecting to a backend object store that could be thousands of miles away, which is, by the way, another problem that we've solved a few slides later. So in this case, let's say you have a single object store, doesn't matter which one, as you can see, we support quite a few. All of your CloudFS nodes and all of your locations will connect to that one, but those CloudFS nodes will be caching the relevant data for that office or that building. And all of the caches will look different because all of the people at all of your sites are doing different things. But they all connect and commit data very quickly to that single source of truth, which is that object store on the back end. This performance segregation, right? Where basically we have the performance of the object store, we have the latency of the communication from the object store to the edge node, but we have that super high performance edge node, effectively makes it look like The users are using the same old storage systems that they always have. So let's see how we architect this. In this example, we're going to have 6 sites. One of those sites will be in the cloud because you may be doing things like with cloud applications, or you may be training an AI on all of your unstructured data. So we would put a CloudFS node in the cloud, and we have CloudFS nodes on all of your various sites. The way that this is architected is kind of mesh, kind of hub and spoke, right? All of the CloudFS nodes actually communicate with each other, but they also all communicate with that backend single source of truth, right? Why do they need to communicate with each other? Because as Petra mentioned, when it comes down to collaboration, which we'll talk about in a second, if you have 2 folks working on the same file that are globally distributed, and they're working on, let's say, an AutoCAD or Revit or even a Word file or a PowerPoint, like you can see multiple people editing, those changes don't have time to go through the backend object store and to another CloudFS node. Those changes need to be told to both at the same time, so that those 2 CloudFS nodes are in constant communication when they're editing a file that supports what's referred to as byte range locking, such as AutoCAD, Revit, Office 365 type of files, that sort of thing. So these CloudFS nodes will offer local performance that looks like those 2 people are collaborating on the same AutoCAD file in the same building because they're working on the same version. And in demos, what we show is somebody in an AutoCAD file can move a door in the US, and someone in EMEA will see that door move on that same picture immediately, right? Because of that constant communication and the byte range lock, which is very little bit of data, because all that really happened in AutoCAD is a shift in the location. So just in 3D space. And that's all that needed to move, right, between the nodes. So we're not talking about a lot of communication here, but they're both working on the same file. So as the slide says, there are no collisions. There's no versioning. It's just very fast work that looks like we're breaking the laws of physics because it's not a commit to the object store and then a commit back up. So the shortest distance between 2 points is absolutely a straight line. By enabling both backend commits to an object store, those CloudFS nodes are constantly saving the most recent information, but they're also sharing the most recent information with one another. So that if I want to open up a file that has been locked historically, let's say we're working in EMEA and in the US, and I'm in EMEA and I want to open up a file that is owned by a CloudFS node in the US, I have to make that request to the CloudFS node in the US to own that lock now. So we never get those types of collisions. We never get those versionings on the back end because ownership of either the entire file or the byte range is only held by one CloudFS node at a time. They cannot collide in those types of requests. So that's the straight line. On the back end, they all do simultaneous commits to that backend object store. So whenever a write occurs by a lock owner, that is the only CloudFS node that can make that commit because it either owns the range or it owns the entire lock on the file. So that's how we make sure that there aren't any of those collisions, there aren't any of those versions, and you don't need to use the FedEx truck to send the same file to 10 different locations because it's massive, right? You can all be working from the same object store on the back end while feeling the performance of being basically in the same building, all collaborating on the same files at exactly the same time. So
and let's talk for a minute about how our competitors can't do this and why we can. Because there's an architectural difference here that I think sometimes people lose this in translation, and it's the mesh that Glenn talked about. And so for most organizations in this space offering global file systems, hybrid cloud file platforms, they don't have the ability for each one of these locations to talk to each other. Instead, what they're doing is taking communications through that centralized object store even. And for many of them, they use the cloud. And so not only do you have some latency impact when you're sending messages to and from the cloud, if they offer file locking at all, file locking is held in the cloud. And so, as Glenn said, the shortest distance between 2 points is a straight line. If one location has to ask the cloud for the lock that's in another location, that's not a straight line. The shortest distance between those points is the 2 locations. It's certainly not via the object store because that's 2 hops and that's slow. The other thing that's really critical here is that if you don't have a complete copy of the metadata for the file system at every one of those locations, then you'll always have a situation where the locations don't know what's going on in any other location. And the only way to do this is through metadata. It's those tiny little packets of data that Glenn was talking about that can move very, very quickly without a performance penalty of any sort over distance, without hogging your bandwidth. And that's how you can arbitrate all of these changes across the globe if you need to. Back to you. Sorry.
Yeah, no, and a neat side feature of our architecture is that we support fully dark sites. So in applications where there is no connectivity to the backend object store temporarily, it could be because of outage and it could be because of a forward deployment for a military application. We can actually still make a CloudFS implementation that is still part of the global file system, but push all the lock management to the CloudFS node that then will go dark. So the users elsewhere can still see the files. They can't get the right lock, right? But they can still read only those files in the rest of the organization. But on that forward system, right, that now is dark, they can still make changes, right? And then when it gets reconnected over satellite or whatever, when it goes live again, all those changes, all those deltas will get pushed to the backend object store. They can go dark again, right? So this architecture gives you the ability to not rely on the resilience of cloud-based object storage, but your users, when that cloud goes down, if it goes down, or if it goes intentionally dark, your users will have access to the data set that is cached on that CloudFS node. Along those same lines, we also have implemented a lot of enterprise reliability within CloudFS. So it's usually with global file systems in the past, you've given up a little bit of reliability for performance and the ability to do global file systems. With CloudFS, we are truly an enterprise solution where we're trying to garner as many nines of uptime as you will allow. So with that, we've implemented cloud mirroring. Historically, we've had a single source of truth, one single object store where everything is written to. That is still true. An option for you is to implement a second one. This is a free feature within CloudFS. It is not free from your cloud provider. So you have to mirror that CloudFS backend object store to a second one. The recommendation for high availability is a different cloud provider altogether, right? So if your primary is AWS, your secondary should be Azure or Wasabi or Seagate Live Cloud, maybe someplace where they're not going to charge you egress fees. And the goal of that second one is just to be a hot standby. So we're basically splitting the rights. If the primary fails, everything will fail over to the secondary. Right? When the primary comes back up, they will resync through the CloudFS nodes. All the deltas will be shipped back up to the primary, and everything will fail back to the primary. In 8.5, we've released another version of both improvement on performance, but secondarily can also be used for high availability. And I'll talk about the caveat there. And it's called regional store. So our larger customers, they don't like the latency from their CloudFS nodes to an object store that could be all the way across the globe. And the reason for that is around the clock work, right? So if someone in the US is doing some work on a massive file, call it a CAD file, what would need to happen in EMEA before the folks showed up is they would need to pre-warm the cache. So it would be an automated function where the CloudFS node in EMEA basically will bring down everything from the object store, all the changes for that CAD file from the object store into the cache within the EMEA node. So what we've come out with in 8.5 is a solution to that problem, but it also solves other problems. And it's called regional store. We can support up to 4 object stores globally within a single cloud provider. So that's AWS or Azure. So it can be HA, but it doesn't have to be. The way that regional store will work is, let's say region 1 is US, region 2 is EMEA. The US CloudFS nodes will all connect to, let's say, US West object store. All of the EMEA CloudFS nodes, if you have multiple sites, will connect to, let's say, Germany region. They will talk to one another, so they will sync to one another to ensure that they are always in the closest sync that they can possibly be when it comes to every individual lock. But it is asynchronous. However, we still guarantee no versioning and no collisions, and here's why. The CloudFS nodes still own the locks. So when changes are happening to the region 1 object store, that means that the US CloudFS node there has the lock or the byte range lock for all the deltas. And the ones in EMEA, all they can do is request a lock or view the changes that are happening to that range or that file. So even though it's asynchronous on the back end between the regions, by the time the lock request is done, the commits are done to that range or to that file. And the EMEA node can actually open that file for write and be guaranteed that they're on the correct and most updated version of that file, right? The live version of that file, because there's still that communication between the CloudFS nodes to ensure that when the lock is transited from region 1 to region 2, that they're all entirely up to date. So this enables you to deploy in the US and EMEA and APAC. All right, we can technically support more than 4, but you have to request information from support because we want to know why you want to make more than 4 copies of a massive object store and make sure that you're aware of the costs associated with that. But outside of that, we can support as many as you want. In this scenario, and what we usually say is 4 is enough to support the globe. And you're going to get local regionalized performance by this solution. What this also offers you is high availability, right? So let's say region 1 object store goes down for whatever reason, then that will connect to region 2's object store temporarily. And so you have that enterprise level HA, but the only caveat is you're within the same hyperscaler. So it's not the same kind of HA that Cloud Mirroring is going to give you should your entire hyperscaler go down. So you're trusting that the same region or different regions don't go down at the same time for whatever reason, which I don't think has actually ever happened. So it should be good enough HA in that scenario. So we talked about Cloud HA. Now let's talk about local CloudFS node high availability. So we have had historically 2 types of high availability. Local HA, which is an exact copy, active, passive standby of the CloudFS node. We understand that that's expensive. So with 8.5, we've solved that problem, right? So, but we still have local HA as an option. So if you want to buy 2 servers or 2 VMs, make the exact same copy, first one dies, second one takes over, instantly, you're good to go. But you've been paying for that secondary CloudFS node to sit there just waiting for the first one to die. We've also had a global HA, and this is for lock migration. So let's say in the last example, region 1 goes away completely, including the CloudFS node. So all of that has gone off the map. The problem is region 1's CloudFS node had lock management. It owned the right locks for a certain set of files because that's what was created in region 1. That's how our system works. If it goes away and you have a global HA node, let's say in the cloud somewhere, or it could be on-prem, it will then advertise itself as that region 1 CloudFS node, and it will become the lock manager. And those are two types of HA that we have had that have worked really well for quite a while. In 8.5, we implemented Instant Node because we know that keeping a second online copy of an HA system can be expensive. And our customers have said, look, if you can bring a second system up in the time it takes for our users to go get a cup of coffee and come back to their desk, about 5 minutes, then that's good enough. And we don't need to keep a second live CloudFS node HA alive as a local HA. So we implemented Instant Node. And what Instant Node does is it brings up another CloudFS node instantly within 5 minutes, including reboot time. And you don't have to have a dedicated HA node. It can just use the VM resources that you have available and then bring itself up, get its metadata from the object store, and we're good to go. So that is a new feature in 8.5 that's going to save our customers a lot of money from a high availability standpoint. They no longer need to do local HA. And from a cost savings perspective, for some reason, unbeknownst to me, people seem to be moving off of Broadcom/VMware. Maybe it was because they recently said the minimum amount of CPUs you can have is 75. Maybe it's that, I don't know. But if they are, Instant Node will help them move off of ESX, off of VMware, onto any other hyperscaler that we support. And they can bring that node up instantly in a different hypervisor and then fail over to that one with as little downtime as is humanly possible. So our support organization is actually using that to migrate our customer base off of one virtualization platform and onto the other one that they've chose that we've also supported. So that's everything that we do with HA. As you see, we've grown over the years to be an enterprise-ready solution. We support the amount of nines of uptime that you'll really give us, right? So some cloud providers have 13 nines of uptimes. If you want to have active passive HA, that's going to basically be sub-minute failover. So it's really choose your own adventure based on cost, but we have a global file system that is very fast, that is also very highly available, and that is rare out there. Now, how do you access this global file system without a CloudFS node? We have Panzura Edge. So basically what you can do is have access to that same global file system capability while on the go, on your iPad, on your Mac, on your PC, on your iPhone. And if you're an Android user, I guess you too. So you have access to the global file system with check-in, check-out, all of the audit capability of Panzura data services. So when you check out a file, it's audited. We know who's doing what. We know the changes. So all the same kind of accountability that you have from Panzura data services to track who's changing files within the global file system and all that, that comes with Panzura Edge. So now you have access to that same set of files, but on the go through Edge. Now back over to Petra.
All right. One thing I'll add to Panzura Edge is that the way that you set up Edge is you simply attach it to one of those Panzura nodes and you choose which one. And so just like every other location, Edge has an up-to-date view of what's going on in the file system. So again, if you as a user on your mobile device are logging into that file system, what you're seeing are the latest changes.
Awesome.
So what we've covered here is Panzura's hybrid cloud file platform. And we've touched on most of the elements here. So the core of the platform is the global file system. That's the thing that takes care of cloud file migration, consolidating your distributed data down into that single source of truth, then distributing those files out globally and doing this fast enough that you can actually collaborate and co-edit files across sites in the same way as you could if everybody was just sitting under the same roof. It also makes your data immutable when it's in the object store, and it takes no more than 60 seconds to get it into the object store, which gives you a global restore point of no greater than 60 seconds at any point. And that's where the immutable snapshots come in. So it's restoring data in CloudFS is as simple as restoring back to the appropriate snapshot. And you can do that for individual files, or you can do it for the entire file system. So you can see how that helps you to easily overcome a ransomware attack. All right, the platform gives you military-grade encryption. It's FIPS 140-3 certified. And if you want to go and look that up, that is the highest grade of certification that's available within the US, and it's also recognized internationally. And that's the grade of certification you will need for things like CMMC level 2 and level 3, and also for any other government projects. It's something that government departments themselves can actually use.
Which is
Cloud
unique
mirroring.
to this space. We're the only ones with that certification within this space.
That's right. Cloud mirroring, we discussed. You can have whichever object store you choose. You can create a private cloud. You can use public cloud. You can use something that is entirely on premises. Panzura Edge is what we've just discussed and what we haven't touched on in this webinar, but you will find in other Panzura webinars. Just take a look on our YouTube channel. Panzura Data Services, that gives you your insights and intelligence overlay, so administrators can see what's happening in the file system, track back user activity, for example, or alert on unusual activity that would indicate things like data exfiltration. And then finally, Panzura Detect and Rescue. And this one is an absolute lifesaver for dealing with ransomware attacks and catching them early. As we just said, you can always roll back to a previous snapshot, but catching attacks early will massively cut down on the amount of time it takes you to investigate. And so Detect and Rescue looks for ransomware in real time. And when it spots it, it turns off the user account that's affected. And so it corrals the attack and then provides you with a tracker to show you exactly what got changed and what else you should look at. And so this not only keeps your file safe and minimizes the damage, which makes it faster to roll back, but it also prevents attacks hitting your systems more widely. Very often the first place you can detect attacks like these is in the files. And so if you can catch them there, then you can save your other systems, which are likely to get hit in the event of a full-scale encryption. And that's it. We're always here when you're ready. If you have any questions at all, check out our YouTube channel, go to our website, send us a message, use our chatbot, whatever it is that you would prefer to do. No question is a silly question, and you won't get the hard sales pitch if you don't want it. So just come to us whenever you're ready. Thanks for listening.
Thanks.